Fuses and breakers, aka overcurrent protection devices. They're critical for electrical system safety, but what are they? Why do we need them? And how do they work? Well, that's exactly what we're going to cover here in lesson number 1 of this Breakers, Fuses, and Overcurrent Protection playlist. My name is Nate, and welcome to the explorist.life Mobile, Marine, and Off-Grid Electrical Academy. Let's get started. So what is an overcurrent protection device? So pretty much everything we have here is either an actual overcurrent protection device or it's a overcurrent protection device holder, like a fuse holder. So we've got fuses of varying different types that we'll get into later. And then we've also got breakers for DC applications and breakers for AC applications. And we've got, the fuse holders to match. We got all kinds of options here, but at the top level, what are they all for? The goal of an overcurrent protection device, whether it be a fuse or a breaker, is to protect the wiring inside of a system so that you're not pushing or pulling too much power through those wires, overheating them, and potentially starting a fire at worst, or at best, your components just aren't going to work. The main takeaway here is that overcurrent protection devices protect wires. So how can a wire become overloaded? Well, there's sort of two ways that this can happen, and the first way is a short circuit. So this is if a positive and a negative wire come in contact with each other, causing a direct short, and a lot of power can flow. At that point in time, the fuse or the breaker is going to trip, which we'll cover that in just a minute, and it's going to shut off power to that entire circuit so that that spot where the positive and negative wire is touching, it's not going to have any power anymore, and so it's not going to overheat and cause a fire. The second way that a circuit can become overloaded is by simply asking too much from it. A great example of this is, let's say in your kitchen, if you're trying to run a blender and a Instant Pot from the same outlet. That outlet only has, probably 12 gauge wire going to it, which can only handle up to 15 amps. And by using those two high-powered devices at the same time, you're asking it to flow, let's call it 25 amps or so. So if you actually tried to flow that much power through that wire, it's going to start to overheat, potentially melt, potentially start a fire. So that breaker or fuse or whatever is protecting that circuit is going to trip and shut off the power to that circuit, preventing that overcurrent event. So how do fuses and breakers work? So fuses on the inside of them, let's use this little blade fuse as an example. It has a really small filament inside of it, which is, we can think of it as a really small wire. And this particular fuse is rated to up to 10 amps. And if we exceed 10 amps, that little filament or wire inside is simply going to melt and going to shut off power through it. That filament, they've done the calculations and everything like that so that if we're flowing more than 10 amps, that's going to heat up and melt and cut off power to the circuit instead of the wire that's attached to the fuse. Same thing with this A&L fuse. It's just this one in particular is rated to 300 amps. So that filament is bigger, and this is a ceramic coating, so it can kind of handle a little more heat, and it's just going to have to get way hotter, aka flowing more power, before that filament is going to melt and stop the flow of power. A breaker, on the other hand, operates in a similar fashion, but it's just an internal mechanism that whenever it gets too hot, it's going to trip that mechanism, and there's going to be a little switch that activates and then cuts power off, and is going to disconnect this stud from this stud down here. This is a DC rated breaker, and over here we have AC rated breakers. These are really typical in household applications. Pretty much every household in the USA has something similar to this. Power comes in through this direction and out through this direction, and that internal mechanism on the inside, whenever it gets too hot due to an overcurrent event, whether it's short circuit or overloading, it's going to trip that internal mechanism and flip that switch, disconnecting these 2 points on the breaker until you try to turn it back on. Now, if you have a short circuit and this is tripped and you try to push it back on, it's just going to immediately turn back off. Similar with this. So basically it's not going to allow you to re-energize a circuit that's going through some kind of like problem, which is going to prevent even more problems. So what's the difference between a breaker and a fuse? And, obviously I just explained the differences on sort of how they work, but why would you use one versus the other? Because, with a fuse, whenever that filament melts, there's no way to unmelt the filament, so you have to throw this one away and install a new one. And this one, you can simply turn that switch back on. And really, even though they work pretty much the same, there's a couple different scenarios where you may use one versus the other. Personally, in all of the designs at explorist.life, we do fuses anytime that there's no chance that we're going to accidentally overload the circuit. For example, if we have a charge controller that's going to put out 50 amps, we know that unless there's a short circuit, it's only going to be able to put out 50 amps. It can't accidentally put out 100 amps because of, we plugged in too many blenders or whatever example we gave earlier. So that's the time that we're always going to use a fuse. Anytime we're going to use a breaker is on the AC circuits, specifically where there's a potential that we could be overloading that circuit by operating too many blenders. Same concept as in a residential structure, house, building, etc., etc. Now the difference there is 12-volt circuits that could be powering something like a bunch of like cigarette outlets, little 12-volt outlets. We use these little blade fuses, and this is simply a logistical thing because the easiest and best way to protect a bunch of 12-volt DC branch circuits like lights and fans and refrigerators and small loads like that is by using a 12-volt DC fuse block. We'll overlay there, and then by putting these fuses in. But these fuses are really inexpensive, whereas this particular fuse here is closer to 20 bucks. And so that's a very, very 101 level of why you would use breakers versus fuses, and where you would use different types of fuses in the system is going to be covered in a video later in this playlist. So to wrap up this first lesson, now we know what fuses are, why we need them, and sort of an overview of how they work. And in the upcoming lessons of this chapter, we're going to dive deeper into, sizing fuses and what fuses you're going to use in various locations in your electrical systems, and the difference between this fuse and this fuse and this fuse and this fuse and this, because it's kind of a lot. So be sure to click up here to watch, and we'll see you in the next lesson. Yeah, if you have 5 blenders going at the same time,
having a party.
If you're having a party,
All kinds of margaritas.
You want stew and margaritas at the same time.
if you don't like stew and margaritas.
It's a lot of liquid.